Uh, this session has been hosted by Grid Analytics India Private Limited, India, Delhi. And today the presenter for this session will be myself, 𝐏𝐸𝐵 𝐷𝒐𝒃𝒍𝒆. I bring around 20 plus years experience in the domain of data science, machine learning, artificial intelligence, and advanced analytics. Along with me, two of our colleagues, Praveen Bharti, a statistical consultant with us, and Preetha Pal, data science associate. They will help and support me during this webinar. So what the agenda we have defined for the today's webinar? The agenda we'll be covering in the today's webinar is the data science concepts and best practices, predictive model management life cycle, visual data science with low code tools, data science with collective intelligence, raw data to model deployment, from the raw data, how we can complete the predictive model management life cycle, and we will achieve our desired goal for optimization. And during this webinar, we will be solving the problem poverty reduction and management. Right? Raw data to deployment, from raw data, how we can deploy our model for the purpose of prediction or the deployment, which can consider or which can give you necessary information to deal with a data science capstone project. So let's get started. Before getting started with the session, let us have a disclaimer. This webinar on optimization using linear regression is designed and intended solely for learning and informational purposes. The session does not constitute professional advice, certification, or job assurance. Example dataset, software tools, and methodology shared are illustrative and may vary in real-world application. Participants are advised to independently validate concepts before implementation. The organizer, speakers, or associate institution shall not be held responsible for any direct or indirect consequences arising from the use or interpretation of the information provided during the webinar. This is our third edition of public webinar. More advanced session will follow. Right? Another episode 2 of optimization will happen in next week. Optimization using design of experiment. This webinar is not an exhaustive training program. Rather, it is designed to provide the essential skills, foundational knowledge, how to build and win with predictive model management lifecycle, which will help and support for the career preparedness needed to begin or enhance your journey in data science as a career destination. So, in line with our theme, or the problem, poverty reduction and management using linear regression, let us give a brief foundation about optimization and linear regression. What is optimization? Optimization is the process of finding the best possible solution from a set of available alternatives, right? Or you can say, because not the word alternatives, because all the desired parameters are available with you. So you can use your best alternatives to achieve your desired goals. Given certain constant, it focuses on maximizing or minimizing depending on your objective or goal, objective function. And this your objective function could be the cost, profit, yield, but primarily the optimization being used widely to achieve the maximum yield, time, or efficiency. Application of optimization, which are the area where optimization being widely used in engineering, economics, data science, logistics, and machine learning. Common techniques include linear programming, gradient-based methods, and heuristics algorithm. By systematically evaluating option, optimization helps in making better decisions and improving performance. In best to our potential, we can improve the performance. Whether designing systems, allocating resources, or training models, optimizations ensure that outcomes are efficient, reliable, and aligned with specific goals. This is the brief introduction of the optimization. So we can optimize everything which we have the potential through the power of data science or through the power of advanced analytics. The brief introduction about the linear regression. All we are aware the linear regression is a very, very old classical statistical and machine learning statistical technique, classical statistical techniques around 200 plus years old algorithm used to model the relationship between a dependent or target or response variable and one or more independent variable. The independent variable is also known as your regressor, input variable, features, parameters, descriptors. There are many names which comes in the literature for independent variable. It assumes as a linear relationship represented by a straight line equation. The model estimates coefficients. Please note this word, the estimate coefficients, which is highlighted in this note. Take a note of this, that minimize the error between predicted and actual values. Commonly using the least square methods, linear regression is widely applied in forecasting, trend analysis, and impact assessment. Across the fields, the linear regression is being used in the interdiscipline like economics, healthcare, and data science. It is simplicity and interpretability and efficiency across the fields like economics, healthcare, and data science. Its simplicity, interpretability, and efficiency make it one of the most popular algorithms for understanding how input variable influence outcomes, right? Even if, even though the linear regression is 200 years old algorithm, today also it appears on the top in best 5 machine learning algorithms. And the reason we see for its simplicity, interpretability, and efficiency to get rank number one as the most popular algorithm. So as we are talking about the our agenda, we will be talking what are the best practices in order to undertake any of the data science project or any of the predictive analytics projects where the forecasting is involved. There are many frameworks are available in the marketplace, frameworks, or you can say the best practices, right? But one of the frameworks which is very, very popular and used as a best practices known as CRISP framework. The CRISP stands for Cross-Industry Standard Process for Data Mining, right? What is the framework is all about? The framework begins with and what the sources reveals as the best practices. Suppose you have any of the capstone projects where prediction or forecasting is involved. If you follow the CRISP framework, your chances of success increases in between to 30 to 40% for completing the project. So what the CRISP framework is all about? The CRISP framework begins with business understanding, data preparation, modeling, evaluation, and deployment. Right? So we'll break it down our problem of this poverty reduction and management within this framework. Let's get started. And this will also support our this predictive model management life cycle. So once we deal with any of the predictive model or forecasting, right? If we follow the CRISP framework, it will help us to complete and win with our projects. For these projects, we'll be using one of the visual data science with no-code, low-code tools. So in the visual data science tool, we will be using a software called Statistica to deal with these projects, poverty reduction and management. Then data science with collective intelligence for the same poverty reduction and management, we will be using a popular data science tool like in a single visual data science workflow. We also will be using your popular open source like R and Python. The R and Python. Then raw data to model deployments that we'll be experiencing during the course of dealing with this problem. So let's get started. I am opening the visual data science platform software Statistica with no-code, low-code tool. I hope you all can view my screen.
Yes, sir, I am able to see your screen.
Okay, thank you, Prabhu. Yeah, so I open the software Statistica, the visual data science platform software with no-code tool. So we'll be dealing with I'm opening an example data set, a relevant data set called property.star from Statistica inbuilt example. Right? If you examine the data set, what I can view from the data set
আপনার আপনি আমাদের যে সার্ভিস দেবেন, অব্লিগেশন কি, রেসপন্সিবিলিটি কি, সেগুলো মেনশন করা থাকবে। এটা একই নয় তো, এটা তো আপনার ওনারের সঙ্গে এগ্রিমেন্টটা পাঠিয়েছেন, যেটা পাঠিয়েছে সেটা ওর ওনারের সঙ্গে হবে। তাও বলছে না আমার কাছে এখনই নেই, কালকে ঠিক আছে কি করা যায় দেখি কাল, ঠিক আছে শেয়ার করতে চাইছি দেবে।
Yeah. So the data set consists, you can see the volume of the data. The data set consists of the 7 variables. The column denotes to the variable, right? And 30C. The C denotes to the cases or the observations. So 30 rows are there. The data has been structured in a matrix, 30 rows and 7 variables. Okay, right? In order to get a deeper understanding about the data description, because for some of the reason, like it has been described in the short form, suppose I wanted to get a deeper understanding about the data, I can go to the data tab. I can go to the all specification. In the all specification, I get the data description, the POP_CHNG that denotes the population change between the 1960 and 1970, N_EMPLD that describes the number of person employed in agriculture, PT_poor that defines percentage of families below the poverty line, tax rate, residential and farm property tax rate. So this is the data description, and the data has been collected from one of the survey in the US in between 1960 to 1970, right? And what you see in the rows like Benton, Cannon, Carroll, these are the name of the counties. Like you can treat like these are the name of the states in the United States of America, and these are the critical parameter has been collected in order uh, 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 to 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 reduce the poverty and manage the poverty, right? So here, out of these 7 input variables, we have one of the variable 3, percentage of people living below the poverty line, that is my response or the target variable. So let's see on the this on the different state, what is the set of alternative? What is the minimum poverty we have received so far? I go here. So I see from this observed data set, I have a poverty of the 13.2 percentage. That is the minimum poverty we have achieved from one of the state, right? Now, my manager or my government has given me a task. I don't know. Whatsoever you do, you take the corrective measures, you adjust the input parameter and bring down the poverty from 13.2 to 10%, right? How, in order to deal with the projects, we can use the data science and see if we see the structure and the nature of the data, most of the data like the columns appears in continuous in nature, right? I see the numbers 13.7, 400, 19.0, right? And as you see in the introduction of the multiple regression, and even my response variable, which is the percentage of people living below the poverty line, that is also in numbers, right? So here, my problem will be a regression problem, right? And since I have the multiple input, this problem will be my multiple regression problem, right? I do have the multiple input, fine. So let's go and solve and approach to achieve towards the 10% of the poverty. we find, like suppose I break it down under the CRIPS framework, business understanding, under the business understanding or the research understanding, right? We have a research goal to reduce the poverty from 13.2, which was the minimum in the observed data set, to the 10%, right? Then the data understanding, under the data understanding, what we have collected the data or the adequate parameters which will best support to my project of the poverty data reduction, like population change, not employed, tax rate, so on and so forth, right? Then data preparation. In the data preparation, we all agree, right? Any analyst or the data-driven research, it requires in between 60 to 80% of the researcher time for the data preparation. But in this case, we have a clean data, so we will skip that step of data preparation. Then model building, the step 4. In the model building, we found by examining the nature and the structure of the data, the linear regression model is the appropriate model since my response variable is continuous in nature or it is in number, as well as my input also that is continuous in nature in numbers. So we will deal this poverty problem with multiple linear regression or linear regression, right? Then come to model evaluation, the step 5. So let's approach this problem. In order to deal with this problem, the Statistica gives the linear regression in the 2 options. If I go to the statistics, the Statistica provides you somewhere around 16,000 inbuilt functionality to deal with the variety of the analytical features. So since we have a multiple regression, the current requirement, I get the multiple regression from here. Under the statistics step, I get the multiple regression. Another way I can get the multiple regression, if I go to advanced models, under the advanced model, because this is a linear model, right? So under the general linear model, I get the multiple regression. So let's go with this multiple regression. Okay. Okay. I will choose or select the variable of my interest. PT4 is my response variable or my target variable, and the rest of the variables are my input variable, right? So there are multiple ways I can select, or you can say the regression. The various literature, it comes as a regressor also. The input or independent variable is also known as a regressor. So I go along with this specification. I have the options, right? So I do have the different option because here the volume of the data is very small, around 30 number of observation we have. If I do have the more large number of data set, I do have a feature of the cross validation. So I can split the data in training, testing, and validation. Typically in a machine learning project we do, but here since our data is very small, we are skipping this step, right? Let's go with this default specification. Okay, so once I click it, I get one of my interactive dialog, or you can say the output dialog. Let's investigate what all the output I get. I get numerous output, but just in best interest of time, we'll explore only the output which are limited with our goal to reduce the poverty from 13.2 to 10%. So what the output I get, if I click the all effects, I get an ANOVA table, right? And believe me, under the R, you use any of the software, open source or commercial, right? You get the similar ANOVA table. right? Here in Statistica, it helps analysts in a way because what I see, the ANOVA table, the SS denotes to sum of square, degree of freedom, mean square, app value, p value. The p value is corresponding to your app value. So here you see some of the numbers. Some of the numbers has been highlighted in the red, right? So what does it mean? This population change, and this red comes with reference to your p-value, which is less than 0.05, right? That means this population change and the PT neural, right? That contributes significantly out of the 6 variables, input variables or independent variable we have. Out of the 6 independent variable, these two, population change and PT neural, that contributes significantly to reduce or to your target percentage of people living below the poverty line. Let's see what else we get. I will be exploring only 2 or 3 whole model R, right? You see the multiple R, right? Since we have multiple input variable, I get a caps R. These R denotes to the correlation, right? So whenever we deal with the linear regression, one of the statistical assumption we have to qualify the between the dependent or your target and independent, your input variable, there should be a strong correlation, right? So here we qualify that assumption because I get 88. So there is a 88% correlation between your target response variable and your independent or the input variable. So this data is appropriate to apply in a multiple regression. Then we have the multiple R square. The multiple R square, you remember the step 5 in the CRISP framework. The step 5 was the evaluation. The evaluations means we will gather evidence, right? Because all things exercise we have been doing for the purpose of prediction, right? So here this multiple R square in the layman, right? In the layman language, I can claim from these numbers 77% of accuracy. I can claim what I predict or what my model predicts. Then I get the adjusted R square. If the R square and the adjusted R square is closer, as I said, we are dealing with a very small volume of the data, around 30 data points. If I take that model and deploy in 1,000 data points, right? If my R square and the adjusted R squares are closer, I can claim my model will maintain a consistency. The rest of the things are just a ANOVA table. Then we have got something called coefficient. This is one of the greatest strength of the linear regression, or right? So here I see the intercept, that is you can say the slope or the starting point. Population change, I see again on the basis of the ANOVA table, I see the population change minus 0.39, right? And this coefficient gives you a sense of your estimate to your response variable. What do you mean by that? If I increase 1 unit in population change, right? Keeping all these other rest 5 variables as constant or the 0, right? So there will be a estimate change in my percentage of people living below the poverty line will be minus 39. Means if my population will increase, the poverty will decrease. Are you getting me? So this is one of the very, very important, and as we have saw in the definition of multiple regression, for the simplicity and the interpretability, this still it holds a ranks as a number, means one of the best algorithm for in the machine learning family of algorithm. Similarly, if I see the PT rural, right? The PT rural, if I increase 1 unit or 1% of the rural population, right? Keeping the rest of the 5 independent variable as constant, then it will increase my poverty. Percentage of people living below the poverty line will increase to the 0.16%. Fine. So this is the interpretation of the coefficient. So this is what we have been investigating towards our goal to reduce the poverty from 13 to 10%. And as we had seen in our CRIPS framework, the step 4 is your model building, right? And the model is nothing but, the model means it is the equation and the function, and that is heart of the every predictive model will do, right? If I go to the prediction equation in the statistical report, if I go to the prediction equation, I get the whole equation here, right? So I can take this equation and I can deploy in the step 5 also. In the evaluation we found in form of the R square, 77% accuracy we can claim from our prediction. So here I got this equation. Let me copy this equation. In addition to that, this model also generates the PMML code. If I click the PMML code, the PMML stands for the Predictive Model Markup Language. I'm saving this PMML code as like the text. In my desktop. Right? Now I wanted to optimize. I got the input setting. Now I wanted to optimize in order to reduce my poverty from the 13 to 10%. Right? So I went to the data mining. Under the data mining, we have a feature called response optimization. I went to the response optimization. I will load my models, what I generated from. I went to the desktop because I have saved the model in my desktop. Yeah, so here you observe what is my target value. I wanted to achieve 10% of poverty. You see, the algorithm being used in the background is the simplex algorithm. I do have the choice: simplex algorithm, grid algorithm, and random. Right? I have chosen the simplex algorithm. That is a very, very popular algorithm being used for the purpose of optimization. Let me optimize this. I get the code output. Right, so here what I see the output, because this is the iteration has happened. Right, you can see mostly like on the 262 iteration, it has been settled down to the 10%. Right, so this is the input, or this is the adjustment I have to make in the parameter in order to achieve my poverty the 10%. Right, so I have taken a note of this, My population change needs to be 19.65. My not employment independent has to be 1586. Tax rate is the 0.79. PT phone has to be 82, right? So I have taken a note of this parameter. Let's predict whether this parameter is working or not. I am adding one cases. I am getting a new case. Yeah. So I got a new case. So that is, since I'm from Odisha, I'm getting new data. So I worked on the parameter which I got from my optimization. I'm putting the number 19.65, not employment. I'm getting 1586. That is the number I obtained from the optimization. Pretty poor, I'm leaving it because I have to predict, and it's a predict. Tax rate is the 0.79. Pretty phone 82. Pretty rural 25 is 30. Fine. There are multiple ways I can deploy this model. But again, I will be deploying this model through the PMML. Alternatively, my colleague Praveen and Pritha will be showing how we have been talking about the collective intelligence, how the same can be achieved using the R and Python also. I go to model deployment under the data mining, rapid deployment, variable selection from the PMML, load model, open, summary of the predicate and residual value. I get the two output spreadsheet. This is my mean square error, 8.85. That is one of the evaluation technique for the multiple regression or the linear regression. I get this number. See, the number, what I obtained from the optimization I work, I'm getting 10.45, right? I'm getting a prediction of the 10.45. So I can reduce the probability because this number slightly mismatching because I had generated some of the decimal number which I skipped in that best interest of the time. Another way we can deploy this model using within the Statistica or in a broader way, right? Because this is a very unique feature of this data science platform software Statistica. You can write any of the mathematical expression here. I am putting the pretty poor that is in my V3. The number what I got in my coefficient spreadsheet, this is the same number, right? We discussed about minus 0.39. So here, the number I obtained from my optimization, let me put this 19.65. Number of employees, I obtained the number from optimization is 1586. I number obtained from the optimization is 0.79. I obtained the number from optimization 82. City rural, I obtained the number from optimization 25. I obtained the number from optimization is 30. So let me deploy this model. Okay. Can you view my screen? Hello, Pritha or Praveen, can you respond,
Yes,
please?
yes, sir.
Yes, sir.
Yeah.
You can see in the percentage of poor in the poverty is 10.5, right? Anyway, because since we have deployed the model, right, we could have made another column. So this is the way we approach through the visual data science platform software Statistica with the no-code, low-code features. We can solve this poverty reduction and management program, and we can reduce the poverty from 30 of the life. Fine. Okay. All right. So this is from my side. Now I would invite my colleague Praveen to take you through using the same thing for the same desired goal using your Python. Over to you, Praveen. I am
Yeah,
stopping
thank
my.
you.
Yeah.
Thank you,
over to Praveen.
𝑉𝑆்वજીત, for this wonderful opportunity to connect with audience through this webinar. So, first of all, I will introduce myself. So, good evening, everyone. Myself, Praveen. Currently, I'm working as a statistical consultant at Grid Analytics. So, let me share my screen. So, is it visible now? My Statistica's ribbon bar and workspace.
Yes, it is visible.
Okay. So here, what the 𝐵𝒐𝒍𝒆 has shown you, I will show you the same thing using the visual data science no-code, low-code tool Statistica's workspace. So here we have why you are using this workspace, because it provides a facility to collaborate with more people. Suppose your team is working on a project and each member has a different task. So each person can do their task and their own part and can club together using Statistica single workspace. And they can also review everyone's tasks using this statistical workspace and contribute to each other's task also. So here you can see I have just uploaded the dataset, poverty dataset, and I have connected the whatever the 𝐵𝒐𝒍𝒆 has shown you through the Statistica's ribbon bar. We can also do the same thing using this workspace node browser. So this is the general linear node browser. And here we can specify the parameters and we choose our dependent variable. I have already chosen with the best interest of time. Dependent variable as PT poor and the continuous predictors, population change, number of employed, tax rate, PT phone, PT rural and age. And rest others options are also there. If we check these options, we will get the output for these options. Then the assumptions of this linear regressions, we can also see them. Profiler, custom test, residuals 1, residuals 2, and many more. We can also generate the code using these checkboxes. So we can generate PMML, PMML4, Statistical Visual Basic, C, C++, C#, Java, SAS. So we have these options to generate the codes. So now, when we run using this green play button, we will get these outputs. Okay. You can see the wheel kind of thing, and the node is running, and we will see the generated outputs. Yes, you can see here all the outputs has been generated. So whatever we can generate from the ribbon bar, we can generate all the outputs in a single workspace, and all the outputs will be generated at one time. You can see like univariate test of significance, column level, test for sum of square whole model, parameter estimates. You can see the parameter estimates, whatever we have seen using the ribbon bar. These are the coefficients minus 0.39, and these are for other variables. So these are the outputs generated using workspace, and the interpretation that will remain the same. So now here is a Python node also. So if a person is analytical clear with the concept, so they can use any one of these tools with their own choice, like the statistical node or the Python node or the R node. So I will show you the Python node. So actually this code has 3 sections. First, I will show you the histogram of the PT poor, because it is one of the assumptions of linear regression that all the variables and the response variable as well as the independent variables should follow the normal distribution. So I will show for the PT poor in a single color, then I will show using multiple color, and then the main crucial step is the optimization steps. So first I loaded the data set using the code. First we need to import the important libraries like pandas, numpy, matplotlib. Pandas for data handling, mostly in the tabular data. NumPy for the numerical calculations, matplotlib for plotting a graph. Then df equal to active dataset. It will load our current active dataset in Statistica. Then print df.columns. It will print the column names. Then have written the command for the histogram of PT poor, plt.hist, and bins equal to 10, color red. It will show the red color. edge color black, line width 1.2. And here I am labeling the X and Y axis. X axis as the PT poor. On the Y axis, we have the frequency and the title of the histogram of poor family. So this was for the single color. When we come to the multiple color graph, so we have extract the PT poor column in a variable name X. Then we write counts bin as np.histogram, and I am defining the bins 10 and then the counts, and then I'm writing for the color for each bar. So my color equal to plt.cm rainbow.np.linespace 0n. So this will generate different colors for the different bars. And this code plt.bars bin edges, it will use bar plot to manually draw the histogram. And then the same process, X label as PT poor and the Y level as frequency. And here is the title of the graph, histogram for PT poor. And the main crucial step is our optimization step. So for the optimization, I am just imported the linear regression object from the scikit-learn library. And then I'm importing the minimize from scipy.optimize. And then I'm commenting this because my data set is already loaded. So we will leave this. Then I'm defining our regression model. So X equal to df dot drop PT poor X is equal to 1. This means it will drop or remove the PT poor column from the data frame, and it will take the remaining columns as the independent variables. Axis 1 will specify the column-wise deletion. And in Y, I am assigning PT poor as the dependent or the response variable. Then model equal to linear regression. This will create a linear regression model object. Model.fit xy. This fits the regression model using independent variables, dependent variable PT poor, and then print current model coefficients. So this command for features coefficient in 𝐺IP x.columns model.coefficients, print features coefficient 0.4f. This means it will print all the coefficients rounded up to 4 decimal places. And this is the command, separate command for intercept and the R squared. These two also will be rounded up to 4 decimal places. Then find the row with minimum PT poor. So this command will find the minimum percentage of the family living below the poverty line in our original data set, which is 13.2. And then I am defining a function named objective. It will take X as input and returns ABS absolute value of model.predict X 0 minus 10. So this will defines an objective function for optimization, and here X represents the candidate set for the predictor values and model predictor X. And this X naught minimum poor, this is used the best row as the starting point and optimize. And bounds equal to df column dot minimum, df columns dot max for column in X columns. This means it sets realistic bound for each variable, means our variable should be within the range in the original data, and this and prevents the unrealistic extrapolation. Then result equal to minimize objective x naught bounds method LF method LBFGS. So here I am using the optimization algorithm, which is LBFGS, which stands for limited memory Broden-Fletcher-Goldfano-Seno, and B stands for the bounded constraint. So it will now, this command prints optimized variables to achieve PT poor 10. It will print our optimized value in our optimization process. And this command print variable value 0.2f, this will print the variable up to 2 decimal places. And the last command, which is PT poor predicted poor equal to model.predict result x 0. This will use the optimized value of the predicted PT poor. So when we run this command, I will get this output. So this was the plot 1, which I have explained for the PT poor and the frequency. This is in red color. And for the multiple color, I have created this histogram. On x-axis, we have the PT poor, percentage of family living below poverty line. On y-axis, we have their respective frequencies. And this is the optimization output. So here on the top, we have the variable depths of the data set. Then the current model coefficients are minus 0.3923, n employed equal to 0.008. And one thing you can note, whatever we get the coefficients from the statistical region bar, we are getting the same coefficients here also. So we can say that we can generate the same result if our approach is right, or if a person know Python or R, they can use their own choice, but the result will be same. And here the optimization steps. So to achieve our optimum poverty, which is 10, we need these specific values, like population change 19.66, n employed 1,500, 1,586.63, tax rate 0.79, and so on. So these numbers are also matching with the statistical driven bar output. And one thing we can note, all these numbers are within the range of our original variables. So one thing we can note that we can already achieve our poverty up to 10% level only, but due to lack of the analytical approach, we are only getting 13.2%. But now after using this BFGS algorithm, we are getting our desired poverty level, that is 10%. And here in the last line, it is 10%. So thank you. This is from my side. Now,
thank you, Praveen, for this nice presentation. Right. So we are because see, in one of the agenda we had this collective intelligence, right? So here we are approaching and solving this poverty reduction and management problem using a visual data science like Statistica with no code, low code tool, drag and drop approach, right? If you know the Python also, you can approach the same way using the Python code. Now I will invite Preeta how we can also approach and solve this poverty reduction and management program using the R node for the collective intelligence. Fine. Over to Preeta. I would welcome Preeta to take over the session.
Thank you, Biswajit. And thank you, Praveen, for letting me connect to the webinar. And thanks all the participants for the patience. Now I will show the same operation using the R node of the statistical visual data science workspace. So, as Praveen mentioned, that we can do if we are conceptually clear, so we can do the same operation using the general linear node of the Statistica, the Python node of Statistica, and in the R node. And we can do the same operation using Excel also or any other data science platform. So let's get started with R. So for this, we will click the wheel kind of button. So here is the code. So first, the DF active dataset is to access the any current active dataset from the Statistica's Visual Data Science workspace. Next, the names DF is to see the actual names of the column. Next, the DF $PT poor, that is PT poor, as Biswajit has described the dataset, the PT poor is our dependent variable of interest. So we have extracted the dependent variable PT poor from the dataset. Next is the Shapiro.test, which is the R syntax for checking the normality, because we are interested to check the normality of the X. Next, the same we have acquired the library NOR test in order to check the normality test for the X, which is Anderson-Darling test. Next, we will build the linear regression model, that is LM command for the linear model, and PT poor is our dependent variable of interest, which is making a relationship with all the other predictors, and it is stored in the model. Next, we will extract the minimum and the maximum range of all the predictors. Here we have written the apply function except the PT poor. So we are interested in extracting all the minimum and maximum ranges of the predictors except PT poor.
Sorry to interrupt, Preeta. Praveen, can you view the screen of Preeta? Because I cannot view the screen of the Preeta.
Yeah, okay, sir. No, sir.
Preeta, please share your screen because we are unable to view your screen.
Okay, sir. Okay, so somehow my screen is hang. My laptop is hang. Sir, is it visible now?
Praveen, can you view the Preeta screen? Yeah, now
Yes,
it is
sir.
visible.
Yeah.
Yeah,
Now
so
is
we
it
all,
visible?
we all set to go. Thank you.
Okay, sir. Thank you, sir. And sorry for the inconvenience also. Okay, so I'm starting from the beginning because of a technical glitch. Uh, so first, I have written the command df is equal to the active dataset. This command has been written in order to access any active input dataset from Statistical's Visual Data Science workspace. Next, I have written the names df in order to know the exact names of column. Next, x is equal to df$pt_poor. So we have extracted our dependent variable of interest, namely pt_poor, from the dataset.
Excuse me. Your screen
Yes.
is not visible.
Okay. Pravin's screen is still not visible?
No, I can
Yeah,
view
we can
your
see your screen. Yeah.
Okay. Okay, so shall I continue or
Please continue.
okay.
Maurya sir, we can share the recording of the session.
All right,
Okay.
no issue.
Okay, please continue, Peter.
Okay. Next, I have written the R syntax for testing the normality of X, that is Shapiro.test, and I have imported one library called NOR_test in order to check normality with the help of Anderson-Darling test by writing ad.test. Next, the model building part, that is we have built up the model by using the lm command, that is lm for linear model. The pt_poor is making relationship with all the rest of the other predictors and it is stored in the model. Next, we have extracted the minimum and maximum ranges of all the predictors except pt_poor. These apply the extracting minimum and maximum ranges of all the predictors except pt_poor. That is our dependent variable of interest. Next, we will check the actual names of the predictors except pt_poor. Next, we have built up an objective function. Here x is a vector of predictor values. So it will make a vector of the optimized predictor values, which will stored in the new data as a data frame. And next, we will extract the columns of columns of predictors from the new data. And next, this squared error to target 10, this means we want to achieve the poverty as close as possible to 10. And the squared error has been taken in order to eliminate the negative value. Next, we have calculated the lower and the upper bounds of each predictors in order to get the predictor values within its realistic range. Next is the starting points. In order to do the optimization algorithm using BFGS method, because in R also I will be using BFGS method. So in order to use that algorithm, as Biswajit has used the simplex algorithm, so here in Python and in R, we are using the BFGS algorithm, another famous algorithms for optimization. A starting value is needed, or it is called an initial value. So the starting value I have taken as the midpoint of lower bounds and upper bounds. Next is the constraint optimization, because as we want our predictors to fall within its range, here we use the optim function to optimize the predictors as per the objective function and the starting value. Here method is LBFGSB, which means which full form is limited memory Broaden Fletcher Goldfarb Shano bounded constraints. Here lower is equal to lower bound and the upper is equal to upper bound. So optimization of the predictors will be done by this method within the lower bound and the upper bound. Next, we have written the command for extracting the best values of the predictor or the optimized desired values of the predictors, which will store the predictor value in the best values as a data frame. Next, we will try to find the names of the new predictors. Next, it will calculate the percentage of poor, that is PT poor, using those new predictors value or the new optimized predictor value. Next, if we click OK, and next we run the node, it will produce a reported document here. So if we see that here, after extracting the minimum and maximum range of all the predictors, here for every predictors, these are the minimum and maximum range. For population change, it is minus 16.2 and 40. Number of employed, for it is 15.86 to 11,500 and likewise. And above, it has calculated the coefficients of all the predictors as it was calculated in the Statistica and in the Python also. And all the three values of coefficients in all the three platforms are same if you check it carefully. Next, after checking the minimum and the maximum range and after doing all the operations, if we check the final value of the or the best predictor values, we can see that population change is 31.71%, number of persons employed is 5,757.8, tax rate is 0.4, percentage of people using phone is 71.70%, percentage of people living in the rural area is 44.5, and the median age is 35.9, which is very well within the predictor's original range. And if we use the same predictor's value as the optimized value, we will get the value 10. So this value may not match the values calculated in the Statistica or Python, but this is another set of predictor setting which will lead the percentage of poverty, percentage of people living below the poverty is 10. So in this manner, using the Statistica, Python or R or any other data science platform, if we are conceptually clear, we can do the same operation very well. So thank you.
Thank you, Preetha, for this nice presentation for collective intelligence. We can approach and solve our poverty reduction and management program using a visual data science platform software like Statistica. But if the Statistica is a commercial software, but if we would like to achieve the same and with the no coding and the low coding tool, we can also by using the R of open source like R and Python. So that could be we can achieve the same using so can you view my screen, Praveen?
Yes,
Yes,
sir.
yes.
Okay, so let me just have a quick walkthrough of the agenda before we sign up for today. So what our agenda was? The agenda was data science concepts and the best practices. For the best practices for data science capstone project, we apply or we follow one of the best practices framework called CRISP framework, cross industry standard process for data mining. We saw the predictive model management life cycle. What are the steps we need to consider and apply in order to achieve or manage our predictive model management life cycle? Visual data science with no low code tools. We use Statistica through the drag and drop operation. We can perform and achieve our desired goals for optimization without writing a single line of the code. Data science with collective intelligence. Since we approach through the collective intelligence, approaching and solving the problem using Statistica, using R, using Python, all in one go in a single visual data science interface of Statistica, raw data to model deployment, raw data like we have the raw data in form of the poverty data set. From the raw data, we deploy the model that could be also considered and that can also undertake as a capstone project, data science capstone project, right? So the next steps would be from our side. Soon we will be sharing the link, this download link for this today's session, right? And if you have any questions, you can reach us out offline. We would be more than happy to answer your queries. Thank you very much for your time and patience for the today's session, and you follow us for the next session. It will be optimization using design of experiment. Thank you very much. And for today, we are signing off.
Thank you, everyone.
Thank you.
Thanks, everyone.
Thank you. Thank you.